Okay, let's do this again. So, when the Angular team a few months ago decided to sort of like introduce RFCs for signals, so I thought it would be rather interesting as an Angular developer for years now to sort of like take us through a journey on how we got to this point or how we are getting to this point because version 16 is not yet out unless it was out today and I haven't checked. But I wanted us to sort of like go to a journey. So a little bit of background on my side. So I started out with Angular JS and then I jumped into Angular as we know it at version 4.0. Actually, to be more specific, version 4.3 and have been with Angular since then. When I should remember the exact version of Angular that was introduced because that's when they introduced interceptors, if I'm not mistaken. And I played with them, and I think I wrote some of the first articles around that. So a little bit unnecessary information for you, I guess. So today, let us look at reactivity and how we got there, or where we are going to be with version 16 and with signals. So, so a little bit about me. So I am Maina Wycliffe. So I'm a software engineer at Franksource and a Google developer expert for Angular. I also author our weekly newsletter, All Things TypeScript. Please subscribe if you can. And also, those are my two social media handles on LinkedIn and Twitter. Please feel free to follow me. Also, apart from Twitter, everywhere else, I am Maina Wycliffe. So feel free to follow me on GitHub and everywhere else you can find me. So without further ado, let's have a look at what reactivity is. And I did this introduction over the weekend in Angular, Kenya. And I had a sort of like a very beginner-friendly crowd, so I didn't go into details. And I wanted to sort of like teach what reactivity is before we can talk about fine-grained reactivity in Angular. So one of the ways I really like to look about reactivity is when we sync the state of things behind the scenes with what the user sees. So sort of like trying to say if someone clicks on the most popular application out there that you can build is the count application. And you have this plus button and minus button. And whenever someone clicks plus or minus, you want the UI to update to show the latest count. And that's the essence of reactivity. So you update the state and then the view updates. So the reactivity is how does the framework, how does your website display the latest information about the user? So one of the things that was popularized by React was view equals to function of state. So if you want to have a specific view, you need to take the state and pass it through a function. In this case, it could be a template, and then you get the current view. So whatever states we have and the function we have, we use to transform that into sort of like a template or HTML file, we will always get the same view. So reactivity is all about change detection or detecting changes where they happen. And these changes can come from a number of sources. This could be button clicks, could be async operations, there could be browser APIs whenever someone resizes the browser or something like that. And these are all sources for changes or possible sources of changes. And you need to be able to consume this within your application, and then the framework needs to synchronize whatever these sources of information and then present this to the user in a way that makes sense to them, which is why we build websites in the first place. So I have talked about change detection, and change detection is the ability for the framework to detect changes whenever they happen. So let's say go back to the count application, whereby we say increase this counter by 1 or decrement by 1. And you want the framework to detect a change has happened and then do rerendering. In this case, update the view so that the user can see the latest information. So this means that we have, so popularly, so these are not the only ones, but the most popular ones are pull-based change detection and push-based change detection. So what do I mean by pull-based change detection and push-based change detection? So for pull-based, the framework checks for changes. The framework goes through the component hierarchy or the component tree from top to bottom or whichever model it uses, and it's going to be checking whether a component has any changes and then updates the view. So this is what Angular has been using for a very long time. And on the other side, we have push-based detection, and this is where whenever something changes, you inform the framework that something has changed. As you can see in the diagram, whenever something changes in one of the components, for instance, when you're using something like React, you can say set state, and then that is going to sort of like tell the framework something changed related this component, and that's going to relate the component and all the child components in it. This is different from what we are used to in Angular, because in Angular we don't really think about our state variables. We only think about them from the context of a class variable, whereby we say this dot x or this dot counter dot plus plus. We don't really care. We don't really care about how does that work behind the scenes. How does the framework do the update? No, Angular does that for us and uses Zone.js for this. So I don't really know how this writes, to be honest, but to expound a little bit. So in Angular, we don't really have set state or similar, or at least until now. If you're watching this in the future, whereby we have zones, remember we are talking about Angular 15 behind, not Angular 16, and it's pull based, so which means the Angular is going to be checking for frameworks, and this is done by Zone.js. And even when you're doing on push change detection, that is the optimization done by Angular on push, that still does the Angular framework has still to check the component for changes. Only that this time it allows you to sort of like tell it, do not check the component unless it's marked for dirty. Do not do CD unless it has been marked as dirty. Otherwise, skip it. So that doesn't change the overall framework change detection model. Just allows you to optimize and prevent the framework from doing this for performance reasons, so that if you have like a very large application, you don't have to go into details of checking all components and doing in your performance, because that takes a little bit time. So the title of this talk talks about fine-grained reactivity. It talks about our journey to it. So the question is, what is fine-grained reactivity? So when you talk about reactivity, we talked about reacting to changes. What about fine-grained? What do we mean by that? So imagine this: if a change could be detected, when we detect a change, we will know specifically parts of our application, specific parts of our component, our view, that detected, that relied on that change, that were affected by that change, and we only need to read those parts. It's very targeted in that we're able to focus on very specific areas. We can go all the way to fine-grained completed, whereby you could say per element or per node, but we could go all the way per common. But what this means is that we track our dependencies, and whenever you rely on a state variable, we know who is using it and who to inform. Sort of like subscription in ArcGIS, whereby we tell them who to inform, who to tell whenever something changes. So whenever someone's calls .update or set state, we know who is relying on that, and we only inform them, and then the reactivity is only on that specific area rather than the whole application. So let's talk about signals, because I think we have all heard about this noise that has been coming through the Angular community recently. We have the LFC. I think they are closed now, if I'm not mistaken, but it's a good reading, and I have seen a lot of comments from other people. So I'll try to put this as simple as possible, because it's not a deep dive into signals and how they work under the hood. I'm just trying to go over the hood, over everything over on top, so that I can make sure everyone who is new to Angular who doesn't have a good understanding of Angular is able to look at this and understand what they mean. So what's a signal? A signal is essentially a wrapper around a value. So if we refer back to our counter example, whereby we had a count variable which would increment and increment. So if we wanted to make a signal, we would wrap around a signal around that value, And then within our template, we will subscribe to that value by calling the getter so that we can add a dependency. So what this means is that whenever something changes, that those dependencies or those people who have sort of like subscribed, and I know using subscribe here is sort of like taking us through back to, well, that sounds like correct, yes. Maybe not, but to get back to the why not Alex.js data. So for now, let's focus on signal. So if you look at the diagram on your left, you'll be able to see that I have a sort of like an intersection, load intersection, with a four lights, so that we have traffic lights. So if you're approaching from the bottom up, and you get to that junction, you only depend on that single light. That is the single traffic light in front of you. You don't care. So in this case, in our case, it's light B. You don't really care what happens at A, D, or C. Your only point of concern is B. So if B tells you to stop, you stop. If it tells you to go, you go. You don't care. You don't do anything if light C, D, or A changes. And that's the whole idea behind signals. You are now subscribed, or you are now listening to only the signal in front of you, in this case B, and only going to change or going to react if we use our title of the topic for that. So with signals, we are able to do manipulation of the wrapped value. So we have updates, we have getters. This allows us to have very fine-grained reactivity. We also have effects. For those of you who are familiar with React, this sounds like use effect, but this allows us to listen to changes and do something based on those reactions. And then we have computer signals, whereby you can derive signals from other signals. So whenever, like, we can compose multiple signals into a different signal, and whenever one changes value, then everything changes. One of the beauty about signals is that, okay, not beauty, but advantages of signal is that it automatically tracks its own dependencies. And this is why we need the getter. So signal, then the function. And this allows us to know who exactly to inform whenever something changes. So we have talked about signals. What about signals in Angular? So I want to first state these things are not going to be coming immediately in version 16, not everything. This is a possible future that I really like to think about where Angular is going to be, maybe at some point in the future, maybe version 17, maybe version 18. We don't really know, because as the team is going to be collecting a lot of feedback from the community, things are going to change and things are going to be updated here and there. But a few things to keep in mind: we are going to start at some point in the future, we're going to have signal-based components, and this will allow us to sort of like disable the on-put change detection. And if you had like all your components were converted into signal-based components, you'd have like you'd be able to have options on JS. You'd be able to have like you'd have like a fully on push detection, rather than the hybrid, whereby when you have mixed signals. Something else is we have component change detection. Whenever something happens within the component and someone is not using it elsewhere, that change detection is very localized to that area, and this can be localized to per view. And in Angular, views are not just templates. It means that template could have multiple views. When you have things like ng template, ng containers, those are different views, even if you have multiple of them within the container, within a template. So you're able to have localized change detection per view within the template, so that change detection is even more localized. So other things to keep in mind is at inputs, so component inputs, view child queries, models with signals, and change detection will only run if you read those signals. If you don't read those inputs and then those values, and you have passed them into a component, then change detection is not going to be running, because you don't have dependency within that component. So earlier, before I talked about why not Alex.js, so I kept referring subscribe, and maybe it's the wrong word. Someone probably correct me somewhere if I'm wrong, but in the gist of it, that's how it's. So the first thing is that observables are asynchronous by nature. So one of the biggest area where observables or RxJS really shines is when you're doing operations like HTTP GET, when you're doing like listening to event stream coming in. And this means that observables don't have an initial value. And when you're using it within the template, or whenever you're using observer within the template, you need to either subscribe within the component, either within the component lifecycle, or using a sync pipe, which does the subscribing for you. Also, the other thing you have to keep in mind is if you've subscribed to something, you also have to unsubscribe, and so on and so on. So these are the kind of things observables need. But with RxJS, with signals, you don't need that. The whole code becomes synchronous. You don't have to worry about when something will happen. You just need to know react to values as they come. So for instance, if you're talking about a call to the database, if it's undefined, show this. If it's defined, show this. If there is a loader. So this is sort of like more of a synchronous top-down approach, more like instead of the approach you're used to, whereby you have to deal with the asynchronicity of the front end. So other things to keep in mind about observables is they have side effects. That means mostly they are not just, you can't, when you're dealing with an observable on your on your template or within your component, it may be a pure function, it may not be. It could be going to the database to do something, it could be manipulating something else. But with signals, that's not the case. So in order to do side effects, you need to use effects, which is more explicit as compared to observables. So this doesn't mean that we don't have a place for observables. And this is something I'm emphasizing to everyone who I meet. That's because RxJS is going to be still great at doing what it does very well. And then signals are going to improve the framework from a performance perspective. And then if you marry the two, you're going to be getting this very nice marriage whereby you are able to sort of like rely on signals for state management, RxJS for async operations. If you're using something like NGRX for side effects, and then you are sort of like able to provide to subscribe to observables and convert them to signals and vice versa and so on. And this also brings me to the point, maybe this is going to be the end of async pipe as we know it, not immediately, but in the future. I don't know. We'll see how that goes out. So this slide is something I usually included because I included it because it's more of like an idea or sort of like thinking, what about the future? How does signals impact Angular? How does signals change Angular? So the first one obviously is going to be improved performance in large application because change direction changes. So, but we need to focus about other possible future benefits. So let's talk about SSI and hydration. So we have currently we have modern hydration techniques that have been progressed by frameworks such as Wycliffe and so on. But with signals and with its own fine-grained reactivity, we might be able to get to a point whereby Angular knows how exactly the state of your application is during build time, and it's able to sort of like create sort of like automatic alerts, things like that. We're also going to get improved DX, whereby we can get hot module reloading, which is really annoying in Angular because you have to load the whole application and fill up the form. So this is something I'm probably looking forward to a lot. Something else that's going to change is mental models switching in Angular. So changes life cycles, effects, RxJS, signal, interoperability. Functions interprets are going to be now a thing. So those are the kind of things that we need to start thinking about. So the next time you see functions in an Angular application, probably won't frown at first. You're probably going to be, let me first figure out what they are doing here. And that's it for resources. That's it for the talk. If you want the slides, scan the QR code on your right. Most of those are RFCs, and also a very nice article by Quick. I usually butcher his name, so I'm not going to try and pronounce it.